Today we're going to talk about the sampling distribution for X bar and the Central Limit Theorem. Okay, notice here that we have a population I have defined of just 5 values. Populations don't have to be large, but they have to be defined properly. So anyway, I have a population here of $2, $3, $4, $5, and $6. Notice how each item, each dollar, is listed only one time. Therefore, our original population has what's called a uniform distribution. Notice that we have $2 one time, $3 one time, $4 one time. Looking at the graph, you can see that $5 one time and $6 one time. So this is called a uniform distribution, and it's a histogram showing that. So here we see again the population is $2, $3, $4, $5, and $6. Notice the first red arrow near the top of the page says, take all the possible samples from the population of size 2 without replacement. First thing I'd like to say is it's important. The ing on the sampling is important because the sampling distribution means it is different than the sample distribution. Next thing I'd like to say is that the sampling distributions always have to be told what size you're going to use. So that we have a small population, so I'm choosing size 2. The next thing, you'll see, I'm doing this without replacement. Oftentimes they do it with replacement. What that means is, notice the top sample, I'm saying 2, 3. Since I'm doing the procedure here without replacement, because it makes the illustration smaller and easier to understand the basic principles I want you to see. The first sample size of size 2, I'm taking out as 2 and a 3. That means, without replacement, means that's the same sample as a 3 first and a 2 second. If we did it with replacement, that would mean 2, 3, and 3, 2 are different samples. And that would make the illustrations, a larger illustration, make it just a little more complicated to understand, to do. So the way we can do this, notice we can start with the first 2 at the top. It says $2, $3, $4, $5, $6. Start with the $2. Just go with 2, 3, 2, 4, 2, 5, 2, 6. Okay, I'm done with the 2. Now I'm going to start with the 3, 3, 4, 3, 5, 3, 6. I'm done with the 3. Start with the 4, 4, 5, 4, 6. Done with the 4. Let's go to 5, 6. All right, and we're done. We've got all of them. You notice I lift some on the left side, that crooked yellow arrow pointing down there. 2, 3, 2, 4, 2, 5, 2, 6. It's on the left-hand side. Then 3, 4, 3, 5, 3, 6, 4, 5, 4, 6, 5, 6. Okay, now notice the second red arrow down there above, so where it says now calculate X bar, which is the mean of each sample. Now let's look at the first one, 2 and 3. So 2 plus 3 is 5, and the sample size is 2, so we divide by 2. 2 plus 3 is 5 divided by 2, so X bar is 2.5. X bar is the average of the sample. So the next one down is 2 plus 4 is 6, divided by 2 is 3. We go down the whole list, so you get 2.5, 3, 3.5, 4, 3.5, 4, etc. And so notice now the bottom red part where it says, notice how the sampling distribution has pushed in on itself, creating a mound. It's actually gotten narrower a little bit, and doing so, it pushes the middle in and makes it higher. This is a very important concept, which we'll discuss as we go along.